do I have control of the screen at the moment? Because these are not my slides right now.
Yeah, you do. You can actually share the screen from, I'll show. I can.
There's some slides at the moment that's being shown, but these are not.
Yeah. So you can actually go.
Just a moment, sir. Like I'll be stopping the share. You can take over the session, sir.
Sorry, give me a moment. Hey, Vinayak, sorry, let me just look for these slides. Sorry, give me a moment. I'm just looking for the slides. It's opening up at the moment. Give me a moment, please.
No worries, Jason. Take your time. It's all good. So
God. Can everyone see my screen?
Yes, sir.
Okay. Hi, everyone. So,
Jason,
thank you, Professor Vinayak, for
Jason, can I just give you a call? Just give me, if you don't mind, we can just have a chat offline. Just give me 1 second. We'll just.
Yeah, sure.
All right, perfect. Thanks, Jason. So over to you.
Yes.
So basically what in today's lecture, today's tutorial, what Jason will be going through is the examples of how we develop, like the different steps of developing a CGE model through this example.
Yep. Thanks, Vinayak. Okay. Can everyone see my screen?
Yes, sir.
Yep. Okay. Cool. Excellent. I believe Professor Vinayak's gone over the basics of what CG modeling is this morning. So as he mentioned, Now what we're going to do is to look at an example of such a model. So this particular model, the link is in the chat room, so feel free to access the link and download the model itself. So this model is a small example we prepared for this demonstration. Now, when you open it up, you'll see there's a bunch of different folders and a bunch of executable files. Now, most of these executable files are on the back end, so there's no any need to run them. So the main two executables that we'll be looking at is the ones on the bottom, the run model executable, and the run model shock executable. These two executables take all the other executable files and all of these folders and use them to produce results for the model itself. So all of the equations, all of the data that Professor Van Eyck went through in the morning, all of that is all in these other folders and files. But as a user, when we're using the model, there's no need to open them up. Really, all we need to do is just access these executable files. So just as a quick demonstration, if I were to run the model, it'll open up a screen, it'll do a bunch of calculations, and once it's done, it'll go through this process of running the model. So I'm just going to stop it for just a moment here. So here you can see there's a bunch of output messages in the command prompt window. These are only for the programmer to look at. As a user, you won't need to really understand any of the information that's coming out of this console log, because once the model has finished running, all of the information we need as users, all of the outputs are going to be located in the outputs folder here. Okay, so if we open up the outputs folder and go again, this will show us all the results of the model run. So I'm just going to terminate the model prematurely here. So you can see these are some of the temporary results from the model. So because of the way this model works, it gives us the answer by going through what's called a general equilibrium seeking process. So this process takes many, many iterations of the code. So you can see here we've got results for the iterations in this folder. If I were to let the model run to completion, so if I were to go back and if I were to double click the executable file and leave it and let it run for maybe 50 minutes, maybe an hour, when it finishes running, the window should close by itself and gives us the final results in this folder here. But for demonstration purposes, the intermediate outputs here during the process of finding general equilibrium, you can find all the results here. Okay. Is there any questions so far as to what we've just seen? No questions. Okay. So again, very straightforward. For the model we've prepared, as a user, all you really need to do is just to run the model. You don't have to worry about any of the equations, any of the data. It just goes by itself. Okay. Now, in terms of interpreting the outputs, let's have a look at an example of an output. So many of these outputs don't really make much sense to us.
Yeah, if you don't mind, Jason,
Yep.
can I put a prompt in there? Can we go, if you don't mind, talking a little bit through the input data, because we did talk about essentially in a CGE model, we end up having the households, we have the firms, and we have the network as well. So if you can just kind of walk them a little bit through the idea of the input-output data and how it currently looks in this, that'll be great. If it's
Sure thing. So in terms of the input data, most of that could be found in this model in the calibration data folder here. If you open up this folder and go again here, you'll find a couple of CSV files here. So these CSV files are the input files for this particular model. So as an example here, so these are all coded. So the names here are coded. They don't mean much for us. But let's take a look at an example. So this R file, this R.csv file represents the regions of our model. So in this particular model, R is the regions of India that which we are modeling. If you open it up, you'll see that there's a couple of numbers here. So these numbers don't really mean much just by itself. However, the way we read these numbers is that each region in India is given a code. So here there are 3 regions. The name for these regions is just region 2, region 0, and region 1. This is a 3-region model. We pretend India is 3 regions. And so therefore we give them the names 0, 1, and 2 for computational ease. And we put them in this file called r.csv, meaning regions of India CSV file. And it's just 0, 1, and 2. In a more complex model, in the large model that we've built, there are a lot more regions. So as an example, if we were to construct a model for India using states and union territories, there will be 30-something regions, right? So you have 30 numbers here instead of just 3 numbers. So really, it just depends on how many regions you want in your model. You can change it around by defining them in these files here. Similarly, there are other things here like I.csv. I represents the industries within the model. So you can see here there are a lot more industries here. In fact, there's 28 industries from 0 all the way down to 27. We just call them industry 0, industry 1, industry 2, so on and so forth. In actuality, each of these industries has a name associated with it within the national accounts. So as an example, Industry 0 is actually the agricultural and allied activities industry within India. However, again, because this is code, this is on the back end, we don't write it using text, we represent it as a number, just to make the code run a little bit smoother. Likewise, 1 is the forestry and logging industry, 2 is the fishing industry, so on and so forth. Every single one of these numbers corresponds to an industry, to an industry sector within India's economy. Does that make sense? Any questions? No? Cool. Okay. But as you can see, right, files like the industry file and the region file gives us information as to what the model's scope is, how many regions we have, how many industries we have. In terms of the actual economics data, we can take a look at a couple examples here. So one, yes, did someone want to say something?
Yeah, I wanted to actually just add a little bit more on the idea of calibration. So the one of the things to remember is that if you remember when we were talking about how the household utility model how are we representing household utility, or how are we representing industries, right? They have all these parameters, but we need to estimate these parameters based on the data. And that's what calibration does, is based on all this data, it tries to solve the simultaneous equations as a set of simultaneous equations to give you what the parameters are. So now you have a calibrated model that represents the economy of today. Then what you do is you can add in a scenario and compare to what that would look like tomorrow. So, thanks.
Yes.
Over to you, Jason.
Yes, thank you, Vinay. Yes, Professor Dixit is absolutely correct. The purpose of having all of these data is to allow us to estimate how the economy behaves. Okay, so to be more specific, this file here, this IOGH file, this represents all of the trade that happens within India. So if I open up this file, you see a bunch of numbers here. This doesn't really make sense to everyone here, but what this effectively is calculating, is recording, is all of the trade that happens in India between industries and between regions. So for example, the amount of, let's say, iron ore that's sent between regions within India, that's recorded in this data set. The amount of bread or apples or petrol that's being sent between regions in India is recorded in this data. Now, the issue with this data set for a model is that just knowing how much bread or how much apple is being sent between regions is not actually enough for us to figure out how the economy behaves, right? Because in the future, let's say in 5 or 10 years' time, these numbers are going to be slightly different because the population will change, because people's preferences change, the economy changes over time, right? So just knowing these numbers doesn't give us any information about how people behave in the future. So the calibration process is what allows us to use this data to figure out parameters that estimate how people behave in the future. And so that is recorded not in the calibration data folder, but in the base data folder. So again, calibration data is all of the raw numbers that we've just discussed. The parameters that Professor Dixit just mentioned, which explains how people behave, that's in the base data folder. So if I open it up, you'll see here, this looks a lot more different. You've got these, variables called alpha, there's betas, there's gammas, right? And if I open them up, these numbers, again, don't make much sense. But essentially, what these numbers do in the base data folder is explain how people and how businesses behave in the economy, which means that we can use this to estimate what happens in the future if changes in the economy happens. Okay, so again, calibration data is the economy today. Base data is information about how the economy might behave tomorrow. Okay, and so given that information, we can then model scenarios like Professor Dixit mentioned, if the interest rate goes up, if the tax rate changes, if we build a new road, if we create a new trade deal with a different country, all of that will change the economy, and we use the parameters in the base data folder to estimate what that will look like using the CGE model. Any questions? No questions. Okay, excellent. But that's what the executable files do here. So what the executable files do is it's actually a 3-step process. The first step is to take the calibration data, the raw data files, and use them to estimate the parameters in the base data. That's the first step. The second part of the run model executable is to use the base data parameters and validates them. So it takes those parameters and then runs a couple of tests to make sure that those parameters are suitable and they match what we expect. And then the third part of the executable file is for testing future changes to the economy. And that third part is where the bulk of the use of CGE models are. In that third step, when you're testing how the economy is going to behave in the future, that's when you as a user can come into the model and insert information. So for example, if you want to know how a trade deal with the United States is going to change the economy, you come in on that third step, put in the necessary data, and then run the model. If you wanted to see what happens if the tax rate goes down by 0.5%, you come in on that third step, put in the data, and then run the model. Okay, so again, first part of the model, second part of the model where you run the calibration data, where you test the base data, that does not require any input from you as a user. It's only that third step when you're testing scenarios for the future economy, you come in and you put in that data. Does that make sense, everyone? Is there any questions? No? Okay, cool.
No.
Yes? No? Okay. Vinayak, did you have anything to add?
Oh, there was something. I thought there was somebody who wanted to ask a question, so that's why.
Yes, I thought so too. But...
Yeah, no, all good. Can we go through an example of a scenario analysis? Like I think there was one scenario you had created on this.
Unfortunately, the data is hard coded, so I cannot insert the data as I wish. Yeah.
All right. Okay. So can you talk through the outputs a bit, if you don't mind?
Yeah, sure thing. So so this is the outputs folder. If you remember, all of the outputs come in here. So a lot of these outputs require you to be familiar with the data in the model here. So for example, this is the aggregated cost of freighting commodities between regions in India. If I were to open that up, right, these numbers is the cost if I wanted to ship iron ore between any two regions within India. So these numbers are all here. However, as a user, it'll take some studying of the model itself, of what these numbers mean, before you understand how to interpret them. So an easy one that we can look at, for example, is something like the commodity price, right? This is the price of a commodity, the price of a good. So here, this lists all of the expected prices of the commodities within India. The price of apples, it's here. The price of iron ore, it's here, right? Now, again, these numbers by themselves don't mean all that much, but what we can do is we can use these to perform a comparison. So this is the cost of commodities that we expect the model to produce. Now, what we can do is, if you remember, right, there's two parts to the model. There's the first part where you calibrate the model, where you use existing data of the economy today to figure out what the behaviors are going to be. So what you can do is you can take the estimated prices of our commodities and then make a comparison with today's prices to see what's going to change. So I can perform an example here. So for this example, I've set the prices of all of the commodities to just 1. Okay, this is just an example. In reality, these numbers will be different. You'll find data for it. But for this example, the prices are all 1. You can see that the model is predicting that the prices are going to change fairly significantly. There are some decreases. So for example, this first entry is decreasing from 1 all the way down to 0.337. This one's decreasing a little bit down to 0.67. Whereas in other industries like this one, the prices are going up a little bit, okay? Now, again, the interpretation for this is not within the scope of the tutorial because this really depends on the data that you have. But for our purposes, what this does is show us that using the model, we've got some expectation of the economy today, and we can use it to figure out what the economy might look like tomorrow. And here you can make a direct comparison. You can see, for example, oh, the prices of apples within Andaman Nicobar has gone down, but the prices in apples in, let's say, Mizoram has gone down a little bit less than that, you know? So these are the sorts of analysis you can do. And of course, this is only one data set. This is the price of commodities. What we can also do is look at values like the GDP of the country. So that's calculated here in firm production, right? You can compare production of today with production of tomorrow. So I can open up an example here. Right, you can see here changes in production. So here it's much less than the changes in prices. However, if you go through the list and go through the numbers and look at the changes, you can figure out all of those changes from these results. Okay. Any questions? No? Okay. Vinayak, was there anything you wanted to add on that?
Nothing from me, Jason. But I'm hoping there would be questions or can we, if you don't mind, once we do the calibration, we end up with like parameters, right?
Yep.
Can we? I think there was a question this afternoon about like let's take the alphas were the, if I remember, I'm trying to remember this. Alphas were the ones for the households, correct?
That's correct.
Yep. So and alpha underscore C was for capital or for consumption, and alpha underscore T was for leisure.
Yes.
So can we just kind of open up that? Let's open up alpha underscore C. So can we go through like a let's take the first row, if you don't mind, and
well, this is just a measure of the preferences for consumption in a household. So the thing is, these parameters are, if we wanted to explain what every single one of these parameters are, we can do that, but there's documentation for this sort of stuff.
Yeah.
But essentially what this file, as an example, does is explains how much people living in each part of India prefers to spend their time. So this number ranges from between 0 to 1. where if the number is 0, it means that the people in that region, they don't want to work at all. They just want to spend all of their time for leisure. Whereas a number of 1 means that they want to spend every day, every minute of their day working, and they want to spend no time for leisure. So that's what this number is meant to represent. Of course, no one is going to be 0 or 1. It's usually a range of values between it. The larger the number, again, the more people prefer to work over leisure. The smaller the number, the less people prefer to work compared to leisure. And so here you can see a lot of these values are 0.5. This is a default value we set because for a lot of these entries, it's not, how do I describe it? For a lot of these entries, either we don't have enough data to make a calibrated parameter, but for this model, more to the point, is that a lot of these entries are not necessary. So this particular model was built to be used for a very large model of India. Since we've made it so that there's only 3 regions, a lot of these entries are going to display strange behavior like this. But the important thing is that the values here mean something much more abstract. So this does not mean the amount of apples or the amount of petrol. It's really just how much do you want to spend your time working versus leisure, right? This is not something that's recorded by the data. No one goes out and surveys people like that. So really we have to estimate these values based off of our calibration data. And all these examples here are similar to that. So gamma here, gamma is the preferences that people have for different regional commodities. So this number, for example, if I were to sell you an apple, do you prefer apples in Delhi compared to apples in Maharashtra compared to apples in Mizoram? So this number is supposed to represent that preference. It's the same product, but where you buy it from, does that matter to you a lot? 0 means that it doesn't matter. 1, it means it matters a lot. Okay, but that's all these parameters are. They just describe how people behave in the economy, what their preferences are, from small to very large.
Perfect. Thanks a lot. Thanks, Jason. Any questions, guys? Anything you'd like us to discuss?
Hello.
Hi,
Hello,
Manish.
Jason. Yeah, I have one question. You say we do a calibration, right? So in calibration, can we use a regression to prioritize our all these thing? Means that Excel sheet that you coming
So
as a final output.
I'll take that. So essentially, that's pretty much what when we do when we double click calibrate, it's not doing regression so much as you have a set. You remember when we were doing equilibrium, we were doing a set of algebraic equations and trying to solve for it. This
Yeah.
one is basically doing that. We have all these parameters around, like you remember the Cobb-Douglas function we talked about. So we had the Cobb-Douglas function. So in the Cobb-Douglas function, we have these parameters alpha and beta. So we have all these equations which we discussed, such that you have the market equilibrium conditions where the supply is equal to demand. So when you have all these such equations you're solving for equally, like it's simultaneously, that's when you're able to generate that. So the calibrate is actually just doing that.
Okay. So
If you
in
want, I
this
can
case,
add something on top.
Yeah,
Sorry,
please
Manish.
go ahead. So no, please.
So that comment, thank you for the comment, but the comment about regression leads me to believe there might be a slight implication here we haven't discussed. So in CGE modeling, the calibration is not statistical. there is no statistics involved in calibration of CGE models. When you talked about regression, right? Regression is a statistical method. So as an example, if I picked someone at random and I ask them, do you prefer to work or do you prefer to take leisure? That person may have a probability of high probability of wanting to work or a low probability of wanting to work. So if I pick any one person and ask them that question, then yes, we might have to regress their preferences. But the thing about CGE models is that it is an aggregate model. We are not looking at one person or two people. We're looking at the population of India. We're looking at all of India. And usually what we observe when aggregated is that there is really not much point to doing statistical methods for some of these, for these aggregate level economic analysis. And so therefore, when we calibrate, we don't do any sort of regression modeling because we accept that at these large levels, statistical methods tend towards the expected value anyway. So therefore, we just do this in an analytical method. We, like Professor Dixit said, we have the simultaneous equations, and then we just solve for those unknowns rather than trying to statistically estimate them. So there is no regression involved here.
Okay, sir. But in calibration, can we prioritize anything, or we can just calibrate our whole data? For example, we are calibrating the Maharashtra state road network. So in that, we have prioritized the arterial, subarterial road in this category, or throughout the network we calibrated in a single model.
Let me take that. So, Manish, the idea of prioritization does not happen here. It is just a system of equations which we are solving to get the results. Now, we can develop the model. We can specify the model to either include smaller roads like regional, like residential roads, or we focus on the larger roads like arterials and national highways. So it really depends on the type of analysis you're doing. Usually we don't, in the CGE model, it's a macro model, right? So in a macro model, you're only interested in looking at the important roads. So when you're building your network, it's the important transport links that you build out.
Yes, got it.
Yeah, perfect.
Thank you.
Any other questions?
Vinayak sir, are you show in previous slide that you are showing in the final output we see a graphical representation. So can we see that graphical representation from that JSON's data as a final output?
Oh, the graph. So like the shape files, like looking at, so one of the things, Jason, I was showing them was the India model where we could look at the shape file and what was the impact. Because this is a small model, we generally would do a graph analysis. So we couldn't, because it's these 6 regions are not really have a shape file. I don't think we created a shape file. We just have links between these regions. So you can literally, because you have only 3 or 4 regions in this. How many? I think, was it 3 regions?
It was 3.
3 regions. We have only 3 regions. You can literally do a bar chart for each of them.
Okay.
I think to answer the question is, yes, we can produce a map like Professor Dixit showed. It is possible, right? If you remember, one of the files we showed was r.csv, which was the regions in India, right? So as an additional step, once your outputs have been produced, you can take the outputs and then also take the shape files for India and then combine the two into a map like the one Professor Dixit showed you. Like he said, we haven't done it for this example because there's only a couple regions. A map isn't really useful, but definitely it is something that can be done if you really want.
Any other questions?
I think, sir, no.
Okay. I think that's all we have for today, actually. Then, if
So the general question I ask, so
yeah,
how many times required for Jason to develop in such this model? I know he doing his PhD on it, but it's 1 year or 2 years or more than that.
oh, so I'll allow Jason. I think that's a question for Jason more than me because he developed it. I'll just give an initial thing. So when you're developing the first time, it's always hard, but it might be much quicker for Jason to do it now. So hand it over to Jason.
Yeah, thank you, Vinayak. The process of developing the model, the bulk of the time really is understanding all of the equations that's really used. Because if you don't understand the equations, you won't really know what data to gather. So that part, it took me a couple months to wrap my head around the process of the equations and where the data might fit in. That took a couple months. Once that part is done, the next most difficult part is the collecting of data. Now, for India specifically, this question is more difficult than for other countries like the United States or Australia, because in India, a minor problem, it's a relatively major one for the model, but is that a lot of the statistics, a lot of the data is not available in a central manner. So what I mean by that is, if I wanted to, for example, know people's consumption habits, right? In Australia, our census collects all of that data very thoroughly. So it's very easy for us to get that data here. Whereas in India, India does have a census. It does have a household consumption expenditure survey, but the data there is very quite limited, right? We know how much people pay for their petrol, pay for their food, but there's not much information on how much they pay for their insurance, right? There's not much information on how many hotels people go to, if any. So because there's a lot of missing data, there was a lot of time spent trying to figure out what those numbers might be. So that process for India took probably about 2 years, 2 years or 3 years. But that's because we kept coming up with ways of finding those numbers and then figuring out they weren't working. It was really just a back and forth process. We imagine that in the future years, once India's statistical capabilities begin improving, and they are improving, but once they get to a level where they have all this data centrally collected, the time is going to become much, much faster.
And also, once you have the first model, all right, like things become much, much easier. I remember when we developed the first traffic simulation model for India, it was really hard. But then it became easier because people understood. You start improving ways of getting data and all of that. But yeah.
Yes, sir. Got it.
Any other questions?
I guess no questions, sir.
All right. So I think what we'll do is we'll stop for now, and happy to discuss. Yeah, the next. Any other questions? As promised, tomorrow I will do an example on safety, the highway safety model.
Sorry, sir. Last question I have.
Yeah.
As you mentioned that we have collected the data from India for various agencies. So how can we means rectify that data we collected are uh, right or wrong, or that will be properly applicable for our models or not? Because there will be a lot of checks we have to be implemented in that model, because it is a huge model. It is not a one day work. No.
Can you say that again? I'm not able to understand. Sorry, the
So
question.
how can we validate that data is right or wrong? Is that data we get from the various agencies from India? So how can we know that data will be proper or not? Means there will be any misunderstanding or any incorrection in that.
So as Jason, it's a very valid question. As Jason was mentioning, that probably has taken us 2 years itself.
Yeah. Okay.
So it's a big problem. But
Okay.
the thing about it is that is always going to be an issue when you're developing such a model for the
Yeah,
first time.
yeah. I got it. It is. I know it is a big problem in every country, not for India, for every.
And specifically when you're building it for the first time.
Yeah. Yes, sir. Thank you.
Thank you. Sounds good. Anything else? All right. I'll thank you, everyone, and we'll take it. Thank you very much.
Yes, sir. Thank you. Thank
Thank
you,
you.
Jason.
Thank you, sir.
Thank you. Thanks, Jason.
Thank you, Vinayak. Thank you, everyone.
Thank you. Good night.